Solutions and dilutions by Nabil. A solution is a liquid homogeneous mixture with two or more components. The component that is the majority is called the solvent, and the component that are in the minority is called the solute. So accurately determine the mass of a solid necessary to make a specific volume of a specific concentration. For a solution of sugar and water, we can use two equations. Molarity times liters equals moles, and moles times molar weight of sugar equals grams of sugar. We get 342.3 for molar weight because that is the grams per mole. To make the to make a zero point 0.1 solution, we would have to do 0.1 molarity times 0.05 liters, which would equal 5 times 10 to the negative 4 moles. We now know how many moles of sugar we need for the zero point 0.1 molarity. Then we do 5 times 10 to the negative 4 times 342 grams, which equals 0.172 grams. When we round to 3 sig figs, we must weigh out 1.72 grams of sugar and add it to 0.05 liters of the water for the zero point 0.1 molarity solution. So how do you physically make a solution from a solid? So basically, you put some solvent in a volumetric flask, which is some water, and then we add the solid to the flask, and to start to dissolve, and then we fill up the rest of the the flask with the solvent up to the line, and then we mix well. So we can do this with a stir bar or inversion, which is just flipping it over and over. So this would be to get a good mix, you do 12 to 13 times. So you'll get a better idea of inversion when in this video. So basically, before I measured it out, I even started measuring. I zeroed the scale before I added the cup in, and then I zeroed it after I added the cup in as well. After I closed the lid. So now then next I can start weighing my sugar. Yeah, this takes me a while because I want it to be exact. Point 0.172. Now we can take the sugar out. Now we just fill up the volumetric flask with a little bit of solvent. And now you can start to add the sugar. And a lot of times there's sugar stuck to the sides of the funnel, so you just want to rinse that out. And a lot of times there's also sugar stuck to the sides of the flask, so you want to rinse that out as well. And after that, you just want to swirl it to get the dissolving started. And now you want to fill up the water to the line. And the meniscus is now at the line. So we didn't have any stoppers, so I added the parafilm instead, and the so we can cover it up and start the inversions. and you basically just flip it over mm, till the air bubble gets to the other side, and you do this over and over again. You just wait till the end, and now you have a solution. So now, accurately determine the volume of stock solution determined to make a specific volume of a specific concentration. So I'm going to dilute a blue dye and a water solution. We are making a calibration curve in class. We have a 0% concentration, which is water, and 100% concentration, which is 5 mLs of dye. So we want a 5 ml solution at the end. So we need to find some intervals between to create a good calibration curve. We will find that 20%, 40%, 60, and 80 between the 0 and the 100. We can use the M1 V1 equals M2 times V2 equation. This means molarity 1 times volume 1 equals molarity 2 times volume 2. We want to dilute the dye to 20%. The concentration of the blue dye is 33 drops per liter. We have everything we need to plug into the equation. So over here, the initial molarity, which is 33 drops per liter, which is times the volume, which we don't know, and 20% of the point two we got from the decimal point of 20% times 33 drops per liter times times 5 milliliters, because we that's how much we want at the end. The So this is the molarity we want. When we solve for V1, we get 1 milliliter of dye. So we must draw 1 milliliter of dye, and then 4 milliliters of water after to dilute it to get a 20% dilution of blue dye for a 5 milliliter solution. So how do you physically make one? You add and you measure out the amount of solute that is needed. You add that to a test tube, and then you add the amount of solvent to the desired volume, and then you mix well. You'll see more in this. So in this, I measured out I used the graduated pipette to I used it to measure out to 1 milliliter, and then I put it in this test tube. And after that, I rinse out the test tube, and now I measure out the solvent, which is 4 milliliters. And then the 1 milliliter plus the 4 milliliters gets to our desired 5 milliliter solution at the end. So now you just mix it at the end. We don't need a stopper or anything because it's not a large amount in the test tube, so it'll stay in. So that's how you make a solution from an aqua. That's how you dilute an aqua solution. And thank you for watching. And this is my presentation on solutions and dilutions.